I'm Ari Arnbjörnsson, and I'm a lead programmer at Housemark. Before we start, I just want to mention that you can get these slides right now at my website, ari.games. And since we're streaming this talk, you can write any questions you have in the chat and I'll answer them at the end of the presentation. So, for the start, it's good to know what Unreal modules are exactly. A module is just a collection of classes, much like DLLs. And Unreal itself is made out of those modules. For example, Slate is a module, and the new ability system is a module. Quick question, how many modules do you think Unreal ships with? The answer, a little over 1,000 modules. There's a lot of reasons why we should split our code up into modules. First one is that it encourages better code practices and code encapsulation. You'll be more compelled to keep your code isolated when it's in its own module. And when you do that, you can more easily reuse code. Since code is usually quite self-contained in modules, you can use those modules in other projects while not having to worry about it being too tightly integrated with the previous project. Unreal only compiles modules that you use in your project. So if you don't use a module, it won't get included in your shipped product. And because of that, you also get faster compile and linking time, since modules that didn't change don't get compiled again. You can also choose when modules load. So having said all that, let's look into how we can go about creating modules. There are 5 steps you need to do every time you create a module, and to remember them, we can use this acronym, BUILD. The first step is the easiest to remember because it's named the same as the acronym. You need to build your modules. Then you need to be able to use your module, implement it, load it, and depend on it. And we're going to go into each of those steps in detail, starting with building your module. For this presentation, let's say we're creating a module called foobar. The first thing we do is create a new subfolder in our project source folder called the same as our module, and we'll create a new text file in there called foobar.build.cs. This build file will describe how to build your module. It also defines what other modules it depends on. There are more things we can do with it, but those are the main things we'll be using it for. The thing about compiling in Unreal Engine is that all projects are built according to target and build files, not solution files. The Unreal Build tool actually completely ignores all solution files. They're just there for your convenience. To generate those solution files, you can run generate project.bat, right-click your uProject file and click Generate Visual Studio Project Files, or whatever code editor you're using. Or, in the editor, you can also click File and refresh Visual Studio Project. It's a good practice to do that every time you change a build.cs file, or if you move source files around so you get the most accurate code assist. And this is what the minimum implementation of that build file looks like. You have a C# class named the same as our module that extends module rules. And in the constructor, we define our module's dependencies. In this case, the absolute minimum we need to depend on is Unreal's core module. Core contains the module handling code, so we can't make a module without it. Next, we'll look at how other modules can use our module. For this example, we'll create an enhanced actor that can have a nickname. First, we create 2 folders, private and public. All headers that other modules should be able to include go into the public folder, while private headers and CPP files go into the private folder. Since we want other modules to be able to manipulate our actor in code, they'll need to be able to include the actor's header file, so we'll put nicknamed actor's header file in the public folder. When working with modules, it's important to know that code from your module is not exposed to other modules by default. You need to mark each function or class explicitly for export. Any headers you don't need or want other modules to include can go into the private folder. Then, there's the primary game module. That's the default module that's created for you when you create a new project. Usually, that module isn't used by other modules, and if you don't plan on exposing anything outside of that module, you can just skip using the private and public folders and put things directly into the source folder. Here's the header file for our example nicknamed actor. It's just a normal actor class with a nickname property and a sayNickname function that might just log out the nickname. This class, as is only exposed to the Unreal editor and the engine. Users can place it in levels and manipulate it via Blueprint. But other modules can't reference it in code, so you can't spawn it from code, cast to it, or call any of its functions. We can add the minimal API class specifier to export minimal type information to other modules. With that, other modules can cast to the class, which allows them to spawn it, extend the class, or even use some limited inline functions. To expose a function for other modules to use, we have to add an export specifier before the function. Unreal creates that specifier automatically for each module in the format of modulename_API, all capital letters. In our case, for our foobar module, that would be foobar_API. Lastly, we can expose the entire class by adding the foobar_API specifier before the class name. That allows other modules to use any public properties or functions of our class. Now we can try to compile our module, but we get an error. Cannot open the include file for actor. Let's look at where the actor header file is located. This part here is the include path, but more importantly in this case, this part is the module it's in. There are two things we need to do to be able to use classes from other modules. First, like we just did, is that we need to include the header file. We need to use the whole path to the header file, starting from the classes or public folder. The classes folder is legacy, by the way. For your projects, always put new classes in the public folder. Then, what we didn't do yet, is to include that headers module as a dependency of your module. And you can find out what any headers module is from its path. It's the name of the folder before classes or public. In our case, that's the engine module. I recommend to use the file path to find out which module a file is in, but it's also listed in the docs. Or you can use other tools like this online classifier where you can just put in the class name and it will tell you which module it's in and what include path to use. That one only works, of course, for engine classes and not your own classes. So let's add engine as a dependency. But now, instead of defining it as a private dependency, we'll add it as a public one. This is needed because if other modules include our nicknamed actor, they'll also get its include for normal actor. Actually, this is a good time to look more at the differences between a private and a public dependency. When you add a child module as either a private or public dependency, it will add include paths to all child modules' public headers. It will also link all of child modules' exposed classes, functions, and variables against your CPP files. So far, no difference between a private and a public dependency. And likewise, a parent module can also add your module as a private or public dependency. The difference between the two methods only becomes apparent in this case. When your module privately depends on a child module, then the parent module will not automatically include the child module's headers or link against its CPP files. In our case, if some module would depend on foobar and our engine dependency was private, parent module would get a compile time error as it would try to include the normal actor header when it includes our nicknamed actor. That's why we should use public dependencies for any external includes in our public headers, so that other modules can include our headers without getting any compile time errors. However, a public dependency will not forward the CPP file linking. Every module must always depend directly on the modules they want to link against. The reason for that is that if you include a header, it will often draw in a huge tree of include dependencies with dozen modules. But when you call a function, you only need to link against that specific object and its parameters. So remember, if only your module's CPP or private header files use a dependency's headers, make it a private dependency. It's preferred as they reduce compile times. Forward declare when you can, so you don't need to mark something as a public dependency. Of course, only when convenient. Forward declaring a class name for a pointer type is easy, for example. I would not forward declare entire function definitions or whole structs, for example. If you ever forget to include a module as a dependency, you'll either get compiler or linking errors. And I want to explain linking errors a bit since I had problems wrapping my head around them when I was starting out. In this example, let's say a parent module wanted to call the sayNickname function on our nicknamed actor, and we get this linker error. That's a lot of text, and it's honestly very intimidating to look at. So let's format it a little bit nicer for our example. I've bolded the 3 important bits in the error. First, we had the CPP file that the error occurred in. In this example, it's in some actor.cpp, but often you'll only get a part of the module cp unity build file. But that's fine, since it's not the most important bit. This part is what it couldn't find. So it couldn't find say nickname in a nicknamed actor. Lastly, and most important for finding where it occurred, this part is in which function it tried to reference it. For this example, I kept nicknamed actor's class as minimal API, but I forgot to export the say nickname function. That can be very often overlooked when moving code into modules. So remember, unexplained linking errors are almost always because of a missing export specifier or a missing module dependency. Alright, now that we know how to use our module, it's time to implement it. To implement a module, we need to create a new file for it. The convention is to call it the name of the module and then append module.cpp. For our module, we'll call it foobarmodule.cpp. In that file, you need to call the implement module function after any declarations there. And this is just by convention. It could in theory be anywhere in any CPP file in your module. But let's stick to the conventions. What this does is that it exposes your module's main class to the rest of the engine. This is how foobar's file will look like. We start by including module manager, then we call implement module and feed it the class name of the module's main class, and then the module's name without quotes. The module manager header is in the core module, which explains why every single module always needs core as a minimum dependency. This main class is any class that extends iModule interface. So a module main class is basically a class that shares the lifetime of the module itself. It can be anything you want. You can create a custom class yourself, but for most smaller modules that just want to contain some class collection, it can just be an empty class. You can either create an empty class yourself, or more conveniently, you can use an empty class that Unreal already provides for you called fdefault module implementation. That implement module line changes a bit depending on what kind of module you're creating. For 99.9% of modules you'll create, it's fine as is. But for game modules, you'll use the implement game module function, and for the primary game module, you'll use the implement primary game module function. That one is usually already created for you when you create a new project. I'll get right back to explaining what game modules are, but first let's talk about what we can use the module's main class for. When you want to create your own module main class, usually implement a couple of functions. Startup module, which is called right after your module's DLL has been loaded and the module object has been created. And shutdown module, which is called before the module is unloaded, right before the module object is destroyed. You can see what other functions you can override in the module interface header. I recommend you check it out. But one great thing about the module's main class is that other code can use it from anywhere. It's basically like a public singleton that is alive as long as your module is loaded. They can simply call load module for your module at any time and call functions directly on it. This is a great power. Use it responsibly. As for module lifetime, during shutdown, modules are destroyed in the reverse order they were created. That means that you can load in other modules during your module start and then be sure that any of those modules will be available in your shutdown module function as well. And let's get back to the concept of gameplay modules. Usually, you only have one gameplay module in your project, your primary gameplay module. You should only mark a module as a gameplay module when it depends on another gameplay module. What that does is that it sets up hot reloading support. Almost any module you create should get used by your primary game module, but not the reverse. So I'd actually be surprised if you ever had to use this. But if you do find yourself in a situation where you'd need a gameplay module, then you can mark a module as one in that module's main class by overadding isGameModule to return true, and then call implementGameModule function instead of implementModule. Take note though that gameplay modules have extra hot reloading overhead, so I'd advise you to avoid making them when possible. But one valid example would be an automation module that tests your gameplay code. Next, we have to load our module. And that's done with module descriptors. Modules need to be described in the game's U project file, or U plugin file if you're creating a plugin. You do that to define when the module is loaded and on what targets and platforms. Here's how we would describe our foobar module in our game's U project file. In the module section, we add this definition which contains the name of our module and its type. The type is used to specify for what targets the module should be loaded. In our case, we want it to be during the game's runtime. That means the module will get loaded in the package game and also in the editor. We can also specify editor here to make it an editor-only module. Runtime and editor are by far the most common types of modules you ever need, but you do have the option of all of these. I won't go through all of them as they're quite self-explanatory, but you can see more info about each of these in the module descriptor header file. The only odd one out here is the developer type. You should not use that anymore as it's deprecated and is replaced by uncooked only. By the way, changing a project's U project file requires you to restart the editor for the changes to take effect. So if you're creating a new module, there's only one point where you have to restart the editor, and that's when. You also have the option of defining a loading phase if you want. If you don't, it will get set to default, which is usually what you want for simple modules that just contain object types. For more info about each of these, you can, again, look at the enums in the module descriptor header file. They're all commented in details there. And lastly, you can white or blacklist platforms, targets, configurations, and programs where you want your module to load on, or not. Lastly, to get the module to compile, we need to depend on it. Only modules in the dependency chain get compiled. You can add your module to the dependency chain in two ways. First, by having it as a public or private dependency of another module in the chain. This is the preferred method if you don't want your module to be compiled if nothing depends on it. For example, if your game needs the module to work, add it as a dependency in your primary game module's build file. There are cases when no other module depend on it. Then you can add it to the extra module names array in your target CS files. Then it will compile even if no other module depends on it. This is usually a rare case that you shouldn't need to use. Of course, the primary game module goes there, but you might also have some custom editor modules that your game requires. But in that case, I'd argue that a better option would be to put those into its own plugin. Alright, having followed these steps, you should have your working module. This might seem like a lot of steps, but once you get the hang of them, you can start making them quite quickly. Also, no one's really expected to remember all of these, so don't shy away from having this written down or bookmarking these slides to check when making modules. That's what I do. Remember that you can access these slides and this video later at my website, ari.games. But we're not done yet. We can't talk about modules without going into some extra content. You won't be a master of modules until you know about precompiled headers, include what you use, default build settings, module logging, and plugins. Let's start with precompiled headers, or PCHs for short. So, normal header files aren't compiled on their own. They're included and compiled into every CPP file. That's a lot of duplicate compiling, especially if you're including a big header file that includes half of the engine headers. If you're always including the same set of headers, why not compile them only once? That's where precompiled headers come in. You'll create one header file that includes your most commonly included headers. That file will get compiled before any other CPP file in your project. It only compiles once and then gets reused on following compilations. It won't compile again unless any of its included headers change, or any headers they include, and so on. One thing you have to be wary of is that if a precompiled header gets compiled again, all other CPP files in the module need to be compiled again. So it's best to only include engine headers or very rarely changing code in it. There are a couple of types of precompiled headers. The first type is a private precompiled header. It's a custom PCH that you create yourself for your module. You define it in your build.cs file using the private PCH header file property. You feed it the name of your private file, and by convention, it should be named your module name private pch.h. So in our case, it would be called foobar private pch.h. You should never include it yourself in your header and CPP files. Unreal Build Tool will automatically inject it for all compiled files in your module. Also, precompiled headers should only be considered an optimization layer. Don't treat it as an easy include all. You still need to include every header that you actually use. And your code should also compile completely fine even if precompiled headers are turned off. The other kind are shared precompiled headers. Instead of defining your own PCH, you can use a shared one. A shared PCH is when a module defines a precompiled header that only other depending modules can use. The module itself can't use it. They exist in some foundational, often used Unreal Engine modules. Actually, Unreal Ed, Engine, Slate, Core UObject, and Core to be specific. Those are the only ones that exist, and those are the only ones that can exist for now, as only Engine modules can create shared PCHs. The best thing about shared precompiled headers is that they only get compiled once, even if multiple modules use it. You can't choose which one to use. Unreal Engine will choose for you based on a priority score from one of your module dependencies. That priority score is sorted per module by how many other modules with a shared PCH it depends on. It's a bit of a weird explanation, but the module list above is already sorted by that priority. So for example, if your module depends on all 5 of those modules, Unreal will pick Unreal Ed's shared PCH to use for your module when compiling it. So when do you use which precompiled header type? You actually have 3 options. You can create your own private precompiled header. This is good for modules with very big codebases, which is often the case with the primary game module on bigger games. You have to decide what to put in that PCH and how to balance it yourself. You can use a shared engine PCH, which is a good option for every other smaller module. And lastly, you can just not use any PCH. It's not really practical, and I don't know a single reason why you would do it unless you're doing some extreme compile debugging, but you have the option. So let's see where you configure those PCH build settings. It's set in the module's build.cs file. There are 2 relevant settings to configure it: PCH usage property, which takes a PCH usage mode enum, and optionally private PCH header file property when you want to use a private PCH, which is just a string path to the header. So, setting the PCH usage mode. Which settings should we use? Well, it's a bit simpler than enum makes it look, because these 3 are legacy, and you should always choose use explicit or shared PCHs. That option uses a shared PCH by default, or a private PCH if you've set one via the private PCH header file property. It's actually already the default setting from 4.24.2 onwards. So if you're using a project that was created on that version or newer, then you don't even have to set this. The setting will probably get phased out in the future. Next, let's look at include what you use, often acronym to IWYU. It's a simple philosophy where, you guessed it, you only include what you actually use. It just means that your code files should only include their required dependencies. When you turn on include what you use mode, then Unreal will warn you if you include one of its monolithic headers. Those are huge headers like engine.h and unreal.ed.h, which just contain a lot of engine includes that were supposed to be convenient, but nowadays they just slow compilation down. They've been marked as legacy headers, so you should stop using them altogether. With include what you use mode turned on, Unreal will also warn you if your CPP files don't include their matching header file first. The reason they introduced that convention is because older code always used to manually include the private PCH as the first include in CPP files. This convention allows us to catch that during compile time. Like we mentioned before, what we're supposed to do instead is to define the private PCH with the private PCH header file property in your build.cs file. And lastly, your CPP file should compile just fine without PCHs and in non-Unity builds. And in case you don't know what Unity builds are, it's when Unreal concatenates many CPP files from a single module into bundles for more efficient compiling. They can sometimes hide missing include errors since many files in a module basically get built together. Using include what you use has been optional up to 4.23, but it was off by default. If you have a project that was created before that version, you can turn on include what you use by setting the PCH mode property to use explicit or shared PCHs in your build.cs file. However, since 4.24.2, it has been set to enabled by default. It's set to default because the default build settings property of a project's build.cs file now defaults to version 2 in new projects. These new default build settings also affect other settings in your project. So let's talk a little bit about those. If you're on a project that was created before 4.24.2, you can upgrade it by setting default build settings to version 2 in your target.cs or build.cs file. What that does is that it sets PCH usage to use explicit or shared PCHs, which enables include what you use style build settings. It also sets B legacy public include paths to false. When that happens, Unreal Build Tool omits subfolders from public include paths to reduce compiler command line length and improve compile times. But because of that, you now have to have every include path correct, where before you could have just included actor.h. Now you have to include gameframework/actor.h. And this can actually be a huge refactor for big projects, depending on how lazy you've been keeping your include paths correct. Luckily, Epic has a tool to help with the migration. You can use Unreal Automation Tool's rebase public include paths command line tool to fix incorrect include paths. It tries a best guess approach, which should get the majority of includes fixed, but you'll probably have to clean up a few stragglers. Search for that tool in the source code to see how to use it. And lastly, it sets shadow variable warning level to error. What that does is that it treats shadowed variable warnings as errors. That basically means that you can't define a variable if a same named one already exists in an outer scope. Now, it's a good practice to have your module use its own log category for easier filtering and also just knowing where log files are coming from. First, you have to declare the log category type. You do that with the declare log category extern macro, which takes in the log category name, its default verbosity, and its compile time verbosity. Log category names for modules are always named log and then your module name. So in our case, it would be log foobar. The default verbosity is what verbosity it starts at when the engine is launched. Display means it shows in the output log window in the editor and gets saved to the log file. And putting compile time verbosity to all means that we can switch between all the verbosities after the game or editor has been launched. If you have some very verbose logging that is computationally intensive, you can filter the code out by decreasing the compile time verbosity, but that also means that you can't switch to that verbosity after the game has launched as it doesn't exist at that time. Then, for example, when debugging, you can just manually change the declaration to include more verbose levels. You can see more info about each verbosity level in the log verbosity header file. So calling that macro will declare a category class that extends flog category. Since it's a whole class declaration, it's most practical to put it into its own header file. Then you can just include it where you plan on logging something. And if you have a private precompiled header, it would also make sense to include that header in there. After declaring the log category, we have to initialize it with our module. You do that by calling the define log category macro with your log category name. What this does is that it instantiates an instance of that log category class, which registers itself with the log suppression system in the constructor. We want this log category instance to have the same lifetime as our module, so you should put it in the same place where you called implement module in the foobar modules CPP file. And lastly, we use the log category. To do that, you use the UE log macro and you give it the log category name, log foobar in our case, a verbosity like display, which in our case wouldn't get filtered out since it's our default verbosity, and finally a normal string with our text. Notice that you can't use Unreal strings with the log macro. And lastly, I'm just going to super briefly mention plugins. They're basically just a collection of modules which you can turn on or off for a project. You can find a blank example plugin in the engine source code in the blank plugin folder ready for you to fill out. And you can also select new plugin from the editor, which has many common starting points for different types of plugins. I recommend checking them out. Alright, that's the end of the presentation. So let's quickly recap. We create a build.cs file that builds the module. We expose functions and classes via macros to use in engine or other modules. We call implement module in module name module.cpp. We set when the module loads in the uproject or uplugin file, and we add it as a dependency of another module or target so it gets compiled. I'll now be switching to answering questions, and remember that you can get these slides right now at ari.games, and I'll also upload this video there after this. Also, feel free to reach out to me. My online handle is Flassari, like there in the lower right corner, And you can find me online on most social media sites like Twitter and LinkedIn. Thank you.